Okay, today is the last lesson we'll have in this chapter. Again, we got a test at the end of the week. Um, so this is it. This last section is word problems. Basically using everything we've done to find max and min's polynomial functions, and it's word problems, trying to maximize area, maximize volume, things of that nature. So we're going to work a couple word problems here in this video, and then obviously work more when you get to class tomorrow. So here we go. Quadratic functions. Okay, here's a quadratic problem. A rectangular dog pen is constructed using a barn as one side and 60 meters of fencing for the other three sides. Find the dimensions of the pen and give the greatest possible area. Okay, the greatest possible area. Well, how are we going to do that? Well, first thing we got to do is decide basically how we're going to get our equation. Okay. Well, we know that we've got 60 total meters of fence, correct? And we know that since it's rectangular, this side is equal to this side. Okay. They both have to be the same length. Okay, well, let's say each side was 10. How big is this last side? Well, if each side was 10, that last side would be 40. How'd you get that? Well, you took 60 minus 20. You took 60 minus 2 times x. Oh, excuse me. I can get a sneeze out there. Okay. Well, now we need to decide, okay, what I'm trying to find the maximum area. Well, what's the formula for area? Well, area is length times width, correct? Okay, well, area in our case is going to be x times 60 minus 2x. Okay, x times 60 minus 2x. All right, well, here we go. Here we go. Let's go ahead and distribute that x through. So a equals 60x minus 2x squared. Okay, there we go. So obviously I did that so you could see that it's a quadratic. Okay, x squared. So the graph of a quadratic is going to be a parabola, correct? Okay, well, let's do this. Let's do this. Let's go ahead and graph this parabola. Oops. Okay. What are my zeros? Well, oops, different color here. One of my zeros is right there, x equals 0, and the other one is 60 minus 2x equals 0, right? Because this is all factored out up here, the second one. Okay. So negative 2x equals negative 60, so x equals 30. So I've got a 0 at 3, or at 0, and a 0 at 30. So we're going to count by tens. Okay, we are going to count by tens. So this is 30. Now we know that a parabola is symmetric, right? It's going to do something like this. How did I know it was negative? Because my leading coefficient is negative. So I know it's going to do something like this. Well, I want the maximum possible area, the greatest possible area. Well, that is going to be at the top of the graph, at the vertex. Now, obviously, I just drew that in arbitrarily. I don't know that that's the max. How would we find that? Well, isn't the max going to happen of a quadratic halfway in between my two zeros? Because that's going to be the middle. And my vertex is going to happen right in the middle of my zeros because the graph is symmetric. Well, this point then is 15. So if I plug in 15 for x, I should get an area that is as big as I can possibly get. Okay, well, here we go. So area equals 15 times 60 minus 2 times 15. So area equals 15 times 60 minus 30 So area equals 15 times 30. And 15 times 30 is 450 meters squared. That's my biggest area I can have. X we figured to be 15. So if that's 15 and this is 15, well, that makes my last side 30 because I have a total of 60. Okay, but the maximum area here is 450 square meters. Okay, and I plugged in 15 because I knew 15 was going to be my max. So if I 1, 2, 3, 4, 5, so my parabola would end up going all the way up here. Okay, and the very top of it would be the maximum area. Okay, all right, let's take a look at the next one. Cubic functions. Squares with sides of length x are cut from corners of a rectangular piece of sheet metal with dimensions of 6 and 10. 6 and 10. The metal is folded to make an x length here. The metal is then folded to make an open-topped box. What is the maximum volume of such a box? Okay, well, hopefully we can see that this side will fold up to make, and all these sides will fold up to make the sides of an open-top box. So we'll get something like this, and this is open in here. Okay. So that's what we're dealing with. We got an open top box. All right. Fair enough. Well, how are we going to find the volume? Well, what's the formula for volume? Volume is base times height times width. Okay. Well, the base. Okay. Let's call this the base. So this part right here is the base is going to be this length. That's how long my base is. Well, that's going to be, let's make this make sense. Let's call this 10, and this 6. Okay, well, my base is, my base is 6 minus 2x, right? Because the whole thing was 6 minus 2x's to just get this length. Okay? My height is going to be the height of the box. Well, that's just x. That's my x. So my height is x, and my width is just going to be this length, which is 10 minus 2x. Minus 2x. Well, now that I have my formula, I know what I'm doing. Volume equals the base, which is 6 minus 2x, times the height, which is x, times the width, which is 10 minus 2x. Okay? 10 minus 2x. Super. Super. Okay? Now, here's what we do. We graph again. Okay? We graph again. Now, cubics are a little tougher. This is why you need a graphing calculator, because it's going to make this a lot easier. What are my zeros? Well, negative 2x plus 6 equals 0. That's this one. Okay, I just rearranged some things. Negative 2x equals negative 6. So x equals 3. So I've got 3. I've got 0. And then 10 minus 2x equals 0. Negative 2x equals negative 10. X equals 5. X equals 5. So we're at 0, 3, and 5. And just knowing what a cubic looks like, this one's going to do something like this, because it's going to end up being a positive cubic because negative times a negative is a positive. Okay? So again, we're trying to find the maximum volume. Well, the maximum volume is going to end up being right in here somewhere, and I'm not really sure how high that is. Okay? Not really sure how high that is going to be. So this is why we need to plug this into our calculator. Okay? And I'll show you how to do that when you get to class. You plug this into your calculator, And then you use your maximum function to find out the top. And what we find here is x ends up being 1.21, and your y, well, I guess I should make it x equals. Your x ends up being 1.21. Your y is 32.835. Okay, not as easy as the last one to get that number because cubics aren't perfectly symmetric. Okay, they're just not. So basically what this means here is the maximum volume I can have is 32.835. That's the volume. And the length of x that I'd have to cut is 1.21. That's how long the x's have to be, the squares that I have to cut out to get the biggest volume. Okay? That's the idea there. So when you get to class, I'll show you how to do the calculator stuff to make this a little easier, and we'll go from there. Okay? Just some word problems, things we can use. Life's pretty good. Again, last lesson of the chapter. Got a test at the end of the week. See you in class.